So very good evening guys. So today we are going to start our first video, that is regarding the chapter. As I said earlier, it is based on the class 11 syllabus. I am going to start with units and measurement. Okay, so yeah, anyway, that particular chapter we have to always discuss. Any chapter we have to always discuss from the basic. So that basic, that everything we are going to discuss it today. So listen to this particular basics in this particular units and measurement. Okay, so first of all, what is that chapter is that? It is that units and measurement. Okay, so how this particular chapter, in this particular chapter we are having some important concepts. What are those important concepts? I am going to tell you now first. Based on that, what are the videos you are going to get in the future, that also you can see it right now. So today is about, I will be discussing about some introduction and physical quantities. Okay, what are meant by physical quantities, units, and then what are the different units for length, mass, time. Till there we are going to discuss today. And tomorrow, that is in the next video, you will be able to get, you will be getting that regarding the concepts of significant figures and as well as rounding of the figures, that one. And then you will be getting regarding the errors and errors in the measurement, and finally dimensions and its analysis, dimensional analysis. This is somewhat time taking one, so if it is required I will split this one into two parts and then we will have the discussion, and then questions or the numericals based on these particular concepts that we are going to discuss as a separate video. Is it okay? So this is what it is going to be regarding this units and measurement. These are few important concepts which will be which are important for your class 11 and at the same time JEE mains or as well as NEET examination. So this is the roadmap for our completion of this particular chapter of units and measurement. So let us start regarding this introduction part of this chapter. Introduction part in the sense, few concepts are there, few important points which you might be knowing or which you might not be knowing. So yes, let us proceed with this. Okay, right, thank you. So you can take this down. So let us come from the simple point, right? Everyone, like, what is meant by physics actually? Okay, physics, if anyone is asking, suppose if your teacher is itself asking, you people give some different answers, right? It is about let me tell from my point of view. You people are able to see me, right? Okay, you are able to see me, you are able to see this, or you are able to listen to me. Okay, or you are able to work with your mobile or laptop. Okay, or you are able to do some what you call experiments. Okay, depending on the few laws which are already happening in the nature. For example, a law is happening in the nature or a particular phenomenon is taking place in the nature. That is, for example, sound. Okay, when I am speaking here, sound will be audible to different people around me. Okay, sound will be audible to different people around me. So there some natural phenomena is actually taking place. So to understand about that natural phenomena and few phenomena that are happening in the nature, that we are going to learn in physics. Okay, so in this, the basic part, it is coming from the units and as well as measurements. Okay, so first of all, let us come to the basic point. What is meant by a physical quantity? Anyone? What is meant by a physical quantity? What is meant by a physical quantity? Yes, few people are already, they might be getting that answer into their minds. That is, any quantity which is measurable. Any quantity which is measurable and it obeys the laws of the nature, or which can explain the laws of physics. That one we can call it as physical quantity. For example, right, you will be able to measure what is the length of this board, right? Okay, or the breadth of this board or area of this board. Okay, At the same time, you will be able to measure, how much intensity of sound is being produced, okay, or we are able to measure what is the focal length of a lens, we are able to measure how much current is flowing through a wire, okay. So these all are any quantity which you can measure, that one we call it as a physical quantity, okay. So you can write it down, any quantity that is measurable, it is called as physical quantity. What are the examples? Okay, so basically there are few examples that I will tell, and at the same time which you can easily understand, those also we will discuss. Okay, that is length. Okay, length of a body, or your height, your weight. Okay. Okay, at the same time, like mass, we can measure the time. Okay, you are able to measure how much time actually I am able to take the class, right? Okay, so that is also a physical quantity. And beyond this, we know that yeah, we are applying some force, we are applying some momentum. Okay, so these all they come under physical quantities. Apart from that, which you already know in your class 10, okay, you might have come across different physical quantities like power of a lens, and then there is one more. What is that? Resistance. Okay, we are able to measure resistance, right? Even voltage or potential difference, these all are, they come under physical quantity because we are able to measure them. Okay, so these are called as physical quantity. Then what about non-physical quantities? What is meant by non-physical quantity? Yeah, obviously, if physical quantity is measurable, non-physical quantity means the quantities or the things which you cannot measure. What are the examples of the quantities which you cannot measure? What will be the example for that? The quantities which we cannot measure. Okay. For example, you asked something to your mother or father. Okay. They didn't provide you that. Okay. So what do you get? You get some angry or frustration, right? Can we measure what is, how much is that? How much quantity it is? No. Okay. So basically, the quantities which are not measurable are human emotions. Okay, whether it is anger or whether it is happiness, whether it is how much you love your parents or parents, right? Okay. Next. So such kind of emotions we call it as non-physical quantities we cannot measure, and this is not our part of discussion right now in this particular physics. Okay. So let me come to this point once. So this physical quantity is actually divided into two types. What is that? First one is fundamental physical quantity and the second one is derived physical quantity. What is meant by fundamental physical quantity? Okay. Already physical quantity means anything which can be measurable. Okay. Then that physical quantity we are dividing it into two parts. That is fundamental physical quantity and the another one is derived physical quantity. What is meant by fundamental physical quantity? Suppose in the nature there are few physical quantities which are independent. Independent in the sense that physical quantity, it doesn't depend upon other quantities. Like for example, time is there. Time is an independent quantity. It doesn't depend upon mass or it doesn't depend upon length. Okay. So such type of physical quantities we call them as fundamental physical quantities. Basically in the nature we are having length, mass and time. Okay. For the timing, let us take these three. Okay. Because in most of your class 11, most of the concepts in your class 11, they are based on mechanics. Okay. In mechanics, most of the physical quantities, they depend only on length, mass, time. Okay. So that's why first I am discussing about this. Yes, there are few more that also I will be discussing. Okay. First you can remember this, like length, mass, time. These are few basic fundamental physical quantities. Next, what is meant by derived physical quantities? Derived physical quantities means the physical quantities that depends on fundamental quantities, fundamental quantities. Okay, for example, you want to find the area of this particular board. Okay, what is the formula for area? Area is equal to this board is a rectangular shape. Area is equal to length multiplied with breadth. Is it okay? Area of this rectangle, it is equal to length multiplied with breadth. So if you observe, area is depending on length and one more length. Breadth is also a length only. But for our understanding of shortest length, we are using it as a term called breadth. So this is also length, this is also length. For example, if you take area of a circle, it is equal to pi r square. It is depending on square of radius of that circle. Okay, so there are few quantities which are actually dependent on fundamental quantities. Those we call them as derived physical quantities. So what are the examples of derived physical quantities? I'll be giving them. Okay, so if you want to take down anything, this just pause the video and then you can take down the points here. Okay, right, I'm erasing this. Right, so what are the examples of these derived physical quantities that we'll see once? So first one is, you can take it as area. Second one, volume. Third one, density. Density is equal to mass by volume, right? Okay, so that's why volume is equal to, if it is a cuboid, you can take it as length into breadth into height. If it is a cuboid, okay, there are many other different shapes, but I am taking it as cuboid for timing. Speed, it is equal to distance by time, right? Okay, speed depends on distance and as well as time. Distance covered divided by time. Then acceleration, it is equal to change in velocity by time, like this. Okay, many physical quantities are there, or otherwise you can take momentum. Apart from that, force. Okay, again stress, which is force divided by area. Force is equal to mass into acceleration. Okay, so these all are few examples of derived physical quantities. Okay, so that is about derived physical quantities. Yes, there are many. For example, potential difference, voltage, electric charge, and at the same time resistance. Okay, power of a lens. Even these all are quantities which actually those are derived physical quantities. Is it okay? So that is about fundamental quantities and as well as derived physical quantities. Okay, right, now let us move on to the next part in this particular concept, that is regarding the units. So first of all, what is meant by a unit? Look at this. What is meant by the unit? Okay. For example, previously, like in olden days, if they want to measure the length of this particular board, they need a constant quantity so that we can identify the length of a particular substance. For example, look at this. This is the hand. Okay, this to this, 1, 2, 3, 4, 5 and something like 5.6. okay, so I am taking here, I am taking that my hand span, this is called as hand span, as the measuring quantity here. Okay, so I am taking this particular hand as a quantity and I am actually comparing that length with the length of my hand. Okay, so how many times I got it? It is equal to 5.6 somewhere. Okay, so if I want to say what is the length of this particular board, then I can tell that it is equal to 5.6 times of my hand span. Okay, but will it be every time equal to 5.6 times of hand span only for everyone? No. Okay, so for example, if another person is having small hand, okay, instead of a hand as large as mine, okay, if they are having somewhat small hand, then in that case they will be getting more length. Is it okay? Instead of only 5.6 handspans, they will be getting somewhat more value. So here handspan is not a constant quantity for everyone. Okay, it is not a constant quantity for everyone. It will be changing from person to person. Okay, but if we want to make a particular physical quantity with a certain unit, that particular unit should be constant quantity. It should not be a variable from point to point. That means from one place to another place, it should not be a variable. It should be a constant quantity. It is easily converted from one unit to another unit, and at the same time it should be readily accessible. Okay, such type of quantity we call it as unit. Okay, so what is actually I already said what is meant by unit. Then what is meant by measurement? Measurement means it is comparing an unknown physical quantity with a known quantity. For example, right now I am having a scale here. This scale is a known quantity. It is already having 30 centimeter. Now I want to measure this particular length of this board. Okay, so what is this measurement means? It is comparing unknown physical quantity with the known physical quantity. We are calling it as measurement. Is it okay? So now in this, just like see this particular units, they will be existing for almost all the physical quantities. Units will be given for almost all the physical quantities, but except a few, like refractive index. This is a physical quantity, but it won't be having units. Okay, like that there are few more that we will be learning gradually as we progress into different chapters in class 11. Okay, so this particular unit, it will be existing for almost all physical quantities, and just like how physical quantities are divided into two types, these units are also divided into two types, that is fundamental units, and the second one is derived units. What is a fundamental unit means? The units of fundamental physical quantities, you can simply call them as fundamental units. That is, like for example, length, mass, time, those are fundamental quantities as well. Length, mass, time, those three are the fundamental quantities. So similarly, for this fundamental units, it will be, for length it will be meter. Okay, for mass it can be measured in kilogram. For time you can use it second. Okay, so that way those are the units of fundamental quantities. So that's why we call them as fundamental units. Derived units means those are units derived from fundamental quantities. Units derived from fundamental quantities. Sorry, fundamental units. Okay, I'm sorry. Fundamental units. We call them as derived units. For example, this is there, right? Area is a derived physical quantity. So area is equal to length into breadth. Length is measured in which unit? Meter. Breadth is also measured in meter. So meter into meter, it will become meter square. If you look at the volume, it is length into breadth into height, so it will become meter cube. Density is equal to kg per meter cube. Like this. These all are the units of derived physical quantities. We are calling it as derived units. Okay, right? So that is about fundamental units and as well as derived units. Let us proceed further. So if you want, you can please take it down by pausing the video. Next. So just like for example, we will be using different terminology. We will be using different terminology or different, suppose rice is there, rice. Okay, that one you call it with different language in different states, isn't it? Okay, in the same way, you can take it just as an example only I said. Okay, in the same way, units of length or mass or time, they are taken with different ways in different parts of the world. Okay, like that, based on that, we are having three different system of units, okay, to represent the units of fundamental quantities. Those are, first one is CGS system, second one is MKS system, and the third one is FPS system, okay, where this is length, and here if you take it as mass, and here if you take it as time, okay. So in CGS system, length is represented with centimeter, that means length only, but in one particular system we are calling that length in, we are measuring that length in which units? Centimeter. Mass is measured in gram, time is measured in seconds. In MK system, meter, sorry, it should be small m, mass it is in kilogram, time is in seconds. Whereas in FPS system, it is feet, pound, and then it is second. Is it okay? These are the three different system of units that used to be, that are used in very olden days, okay, like everyone used to follow their own different system of units. But you know, for example, when scientists, they wanted to share their ideas with another system of units, okay, then surely there will be some confusion. For example, a person who has done all his experiments in centimeter, and if you want to convey his experiments into a scientist who is using FPS system, then it will become slightly difficult. So here comes combining all these three, we have made one particular common system for all this length, mass, time, okay. That one we call it as System International, that one we call it as System International, and in that System International, instead of only 3 fundamental quantities, there are 7 fundamental quantities, those are taken. What are those? First one is length, second one is mass, and the third one is time, fourth one is electric current, okay, remaining I am writing it here. Fifth one is temperature, sixth one is luminous intensity, okay, yeah, luminous intensity means, now for example, you are able to see the brightness in this room, right, okay, how much bright it is, that light is how much, at what intensity that light is present, that one we are calling it as luminous intensity. The intensity of light, we are calling it as luminous intensity, okay, technical name it is. Next, amount of substance, amount of substance. So surely these all physical quantities, they will be having their own units, right? So that I am going to write. For length, it is represented in meter, represented by small m. Mass, it is kilogram, represented in kg. Time, it is represented in second. Yes. Electric current, you already know it in your class 10. Electric current you used to measure in which units? Right? Ampere, capital A. And then comes temperature. It is measured in which units? Kelvin, capital K. Luminous intensity, I don't know how many of you have listened to this. It is candela. It is the candela. Next, amount of substance. Amount of substance, it is mole. Okay, there are, every SI unit is having its own definition. For example, for meter there is a definition, kilogram there is a definition, second there is a definition, ampere also there is a definition. Now for each one there is a definition. If you really want those particular derivations also to be discussed, okay, just drop your requirement in the comment section. So I will, based on that, I will be doing that video on this SI units of, on the definitions of this SI units, okay, right? So please take it down. These are important. That is length, mass, time, electric current, temperature, luminous intensity, and amount of substance are the 7 fundamental quantities in SI system. And what are the units for them. For length it is meter, mass it is kilogram, time it is second, electric current it is ampere, temperature it is Kelvin, luminous intensity candela, amount of substance it is the mole, right? Now apart from these, okay, there are two more quantities which we call them as supplementary quantities. What are those? Supplementary quantities. Those are not completely fundamental like, or they are not completely like derived also. They are unique quantities. That is, first one is plane angle. Okay, and the second one is solid angle. We have to discuss about some points in this particular plane angle and as well as solid angle. Basically, this plane angle is represented by the symbol theta and solid angle is represented by the symbol delta. Okay, so I'll erase it there, and there I will be explaining regarding this plane angle and as well as solid angle. Look at this. Right. So what is a plane angle in the sense? For example, you people know like pizza. Okay, that one. If you take one slice of that pizza, okay, right, or a sector in a circle. Okay, so basically this particular edge, it will be having an arc length. That is an arc actually. It will be having an arc length. And even as I said that pizza is actually part of a circle. It will be having some radius. That radius I am calling it as R, and this arc length I am calling it as L. Let me take this as angle. So what is meant by plane angle means? Plane angle means it is equal to arc length divided by radius, or theta is equal to L by R. Length is measured in which unit, my dear? Meter. Radius is also measured in meter. Okay, so meter divided by meter, there won't be any units, but we have to represent this particular physical quantity with a certain unit. Okay, because it is completely unique there. So that's why the SI unit of plane angle is radian. It is the radian. RADIAN, represented by RAD. Is it okay? Right? So what is this? Every time you people have to remember this particular formula, my dear. Angle means it is arc length divided by radius. What is the angle at the center of the circle? 360 degree, you will say, right? In radian, how much it will be? 2 pi radian, you will say. How it is? Just look at this. What is the circumference of a circle? 2 pi r. What is the radius of the circle? R. What is the angle at the center means? Theta is equal to, what is this total arc length, my dear? 2 pi r divided by, what is this radius? R. R and R cancel, you will get it as 2 pi radian. This is how we will get that, angle at the center of the circle as 2 pi radian. Is that okay? Right? This is about plane angle. Now let us discuss about solid angle. Solid angle. Solid angle. What is a solid angle? It is actually represented in delta. For example, I'm not a great artist here, but let us assume that this is an ice cream cone. Okay, let us assume that this is an ice cream cone. Okay, so now if you look after completely eating that, not like completely eating, at this corner you will be having one particular angle, right? It is not a plane angle. Okay, it is, from all the three dimensions, okay, there is one angle which is formed at this corner of this cone, apex something, right? Let me take that area is DA, and with this point as the center, let me take that radius is R. Okay, so this three-dimensional angle we will call it as solid angle. And what is the formula for that solid angle is, it is equal to DA divided by r square. That is area of that surface divided by r square. Okay, that one we call it as solid angle. Plane angle is arc length by radius. Solid angle is area by r square. Is it okay? Right? For example, if you take a sphere, okay, at the center, and this is of radius r. I hope you all remember what is the surface area of a sphere. Surface area of a sphere is 4 pi r square. Is it okay? Surface area of a sphere is 4 pi r square divided by what is this? R square divided by r square. So r square cancel. Finally delta will be equal to 4 pi steradian. Delta will be equal to 4 pi steradian. Sir, what is this, sir? Steradian is the SI unit of solid angle. Steradian is the SI unit of solid angle, and it is represented by the symbol SR. Please write it down there. Okay, steradian is the SI unit of solid angle, right? So that is what it is regarding plane angle and as well as solid angle. Is it okay? Now let us proceed to the next part. Okay, look at this. So we have discussed about SI system and those different quantities, okay, and what are their units and everything. Now let us move into different units of that length, mass and as well as time. Okay, basically we will be using different units for length, mass and as well as time in different cases. For example, okay, let us take an atom. Okay, at the center of the atom you will be having nucleus, right? Atom, at the center of the atom you will be having nucleus. Okay, what is the size of the nucleus, or what is the radius of the nucleus? It is actually represented very small value it is. Okay, like that, if you go to distance between two, that size of a nucleus is actually very small value. Okay, then comes slowly, you know, wavelength of light. Okay, wavelength of light is also small. You might be knowing or might not be knowing. You might be. Okay, or coronavirus. Okay, size of the coronavirus. Okay, or at the same time, you know, what is 1 millimeter? Okay, there is 1 centimeter on the scale, right? At the same time, gradually it will go to meter. Then it will go to distance between two cities as kilometer. Then it will go to, you know, distance between two planets or distance between two stars. Like that, there are different units of length we will be using in sciences. Okay, so what are those different units? I will be telling you those conversions also in terms of meter. So listen to this carefully. This will be helpful for you in every chapter. Is it okay? So try to remember this particular values, what I am going to write it now. Okay, so put the heading different units of length. Okay, we will be using different units in our concepts for length. Okay, so what are the different units that I am discussing? Okay, that listen to this carefully. First one, it is 1 femtometer or 1 Fermi. 1 femtometer or 1 Fermi. It is equal to 10 to the power of minus 15 meter. Basically, the size of the nucleus is in this order. Okay, size of the nucleus will be of this particular size, or radius of the nucleus. Okay, next, second one. Next one is like 1 angstrom, or you can take it like 1 picometer also. You can take 1 picometer also. Okay, 1 picometer, it is equal to 10 to the power of minus 12 meter. 1 picometer is equal to 10 to the power of minus 12 meter. Next, third one, 1 angstrom. Angstrom means it is basically the wavelength of light, no, that is measured in the units of angstrom. 1 angstrom, it is equal to 10 to the power of minus 10 meter. It is equal to 10 to the power of minus 10 meter. Next, fourth one, it is nanometer. 1 nanometer, 1 nm is equal to 10 to the power of minus 9 meter. Then comes fifth one, that is 1 micrometer. the size of that virus, basically any virus, it will be in the order of 1 micrometer, which will be equal to 10 to the power of minus 6 meter. Sixth one, 1 millimeter, 10 to the power of minus 3 meter. Seventh one, now Ramesh is getting one doubt. Okay, Ramesh means an imaginary character, okay, in our class right now. Okay, sir, why are you always writing it in meter? Because SI unit of length is meter, so that's why I'm converting that everything into meter. Okay, right. Now then comes 1 kilometer. Distance between two cities, basically we'll be writing it in the units of kilometer. So it will be how much it is? 10 to the power of 3 meter. Okay, then comes 8th one, that is, okay, let me write it here. Okay, beyond that kilometer there are other units also, but let us move into the next part, that is 1 astronomical unit. That is 1 astronomical unit. What is meant by astronomical unit? Astronomical unit means it is the mean distance between Earth and Sun. Okay, for example, this is the Sun. If you take this is the Sun, and here this is Earth. Okay, the distance between Earth and as well as Sun, we call it as the mean distance. Why do we call it as mean distance? Means distance between Earth and Sun, it won't be always same all over the year. Okay, sometimes Earth will be nearer to Sun, sometimes it will be slightly away from the Sun. Okay, there won't be much difference, but there is slight difference. So that's why we use the term called mean distance between Earth and Sun. That one we call it as 1 astronomical unit. There is a way of finding that also, so that it is 1.496 into 10 to the power of 11 meter. Okay, if it is in kilometer, it can be written as 1.496 into 10 to the power of 8 kilometer. Okay, basically long distances, I said that we are going to discuss it in kilometer, right? So that's why I'm writing it like this. How do we find that is? How do we find this particular length? It is, now from Sun to Earth, for that light to travel, it will take 8 minutes 17 seconds. And you already know that light travels at speed of 3 into 10 to the power of 8 meter per second. For every 1 second, what is the speed of light? 3 into 10 to the power of 8 meter. Like that, 8 minutes 17 seconds. 8 minutes means 480 seconds plus 17. So it will be equal to 497. Into 3, if you do somewhere nearer to this value, you will be getting. Okay, so that way, because distance is equal to speed into time, right? So that way. Okay, so that is about astronomical unit. Then comes light year. What is 1 light year? 1 light year, yes, obviously you might be knowing it. Suppose if the light travels in vacuum for 1 complete year, okay, that length to which that light will be traveling, the distance to which that light can travel in vacuum for 1 year, that one we call it as 1 light year, and its value is 9.46 into 10 to the power of 15 meter, or it is also equal to 9.46 into 10 to the power of 12 kilometer. Is it okay? Right? Then next one, last I'm writing it here, there is one more unit, that is 1 parallactic second. It is also called as parsec. What is that? Parallactic second. Parallactic second. It is also called as parsec. Its value is equal to 3.26 times of light year. Its value is 3.26 times of light year. Is it okay? So this is the largest known unit which is used to find the distances between few galaxies and at the same time stars and all. Is it okay? These are different units of length which will be useful for you. Is it okay? Right? So take it down. Okay, you can pause the video and then you can take down this particular notes. Okay, right? Just next, different units of mass. So the next one is different units of mass. Okay. Different units of mass. What are the different units of mass? Okay, obviously. So there are few units which you already know, but few more let us discuss. That is one atomic mass unit. What is that? One atomic mass unit, which is equal to 1.67 into 10 to the power of minus 27 kg. Shortcut is AMU. One AMU is equal to 1.67 into 10 to the power of minus 27 kg. Basically, where do we use this particular unit is, it is used to represent the masses of protons and as well as neutrons and electrons. Okay, it is used to measure the masses of protons, neutrons and as well as protons and neutrons. Such subatomic particles masses are represented in AMU. Is it okay? Right? Next. Next, coming to this, that is after this, 1 microgram, it is equal to 10 to the power of minus 6 gram. Okay, then yes, you can write it in kilogram also, but anyway, as we are saying it in gram here, that's why I have written that also into gram. Okay, or this one you can write it as 10 to the power of minus 9 kg. Okay, the 10 power minus 6 gram itself, you can write it as 10 to the power of minus 9 kg. Then 1 milligram, it is equal to 10 power minus 3 gram. Yeah, obviously it will be equal to 10 to the power of minus 6 kg. Next, 1 kilogram, you know it, 10 to the power of 3 gram. Then greater units other than kilogram. Okay, what is a greater unit than kilogram? 2 kg, 3 kg you might say, but used, like for example, if farmers, okay, they grow the paddy and everything, right? So after they actually transport or they export their that rice, or they sell that rice in terms of quintal. 1 quintal. Okay, quintal means it is equal to 100 kg. Okay, if there is any weight or any mass which is of 100 kg, that one we can call it as 1 quintal. Okay, then comes 1 ton or metric ton. Both are same. Is it okay? 1 ton, or it is also equal to metric ton, which is equal to 10 to the power of 3 kg. That is 1000 kg. You can call it as metric ton. So these are few units of mass. Okay, now let us take units, different units of time. Different units of time. Okay, look at this. What are the different units of time means? First let us come from 1 shake. 1 shake, which is equal to 10 to the power of minus 8 seconds. Is it okay? It is the 1 shake which is equal to 10 to the power of minus 8 seconds. And then next one, yeah, 1 millisecond or microsecond. Micro means 10 power minus 6, just like here. Milli means it will be equal to 10 power minus 3 seconds. What are the other units? Second already is there. 1 minute, it is equal to 60 seconds. Then comes 1 hour, it is equal to 3600 seconds. Is it okay? Then 1 day is equal to how many seconds? 86,400 seconds. Or you can write it as 1 day is equal to 24 hours. The 24, if you multiply it with 3600, you will be getting it as 86,400 seconds. That is 1 day, it is equal to 24 hours, right? Okay, 1 day is equal to 24 hours. 24 hour, and each hour is how much? 3600. So 24 into 3600 if you do, you will be getting it as 86,400 seconds. So 1 day is equal to these many seconds. Apart from this, there are another units. Okay, next, what is meant by 1 year? 1 year, it is equal to 365 days. Basically 365.25. okay, but we are taking it as 365 days only in any question in physics. Okay, now what is meant by 1 year? 1 year means it is not just only 365 days. On earth it is 365 days. Okay, so basically 1 year means time taken by earth to revolve once around the sun. We call it as 1 year, and it is basically around approximately 365 days. And then comes 1 decade. 1 decade is equal to how many years? 10 years. We are going to use these terms and everything in mostly in nuclear chapter like that in class 12. Okay, then what is meant by 1 century? 1 century is equal to 100 years. Okay, then comes 1 millennium. How much it is? It will be equal to 1000 years. 1 millennium will be equal to 1000 years. So these are different units. For example, right now this is which year, my dear? 2023. Okay, so I'll remember that this video I am doing it in 2023 now. Okay, right? So this is 20 centuries have been completed. 20 centuries are done, because 20, each century is of 100 years, right? 2000 years are over. Now we are in, after 20 centuries, now we are in the 21st century. Okay, coming to millennium. Each millennium is of how many years? 1000 years. Here how much is there? 2000 years have completed. That means 2 millenniums are over. Now we are in the 3rd millennium. Okay, so this is 21st century and we are in the 3rd millennium. Okay, so anyway, these are different units which will be which you people have to remember, especially for different units of length, mass, and as well as time. Okay, so remaining part, that is whatever those are there regarding the significant figures and rounding of the figures, that everything we will discuss it in the next class. I hope you people are able to understand, and as it is somewhat basic only, I have gone little bit fast. Okay, so if you are feeling anywhere difficulty, just slow down that video, or you can give some pause and then you can take down and try to understand each and every point what we are discussing here. Okay, so that's what. Thank you all of you for this units and measurement, the first video. Okay, thank you all the best.